Hello. Okay, example number 6. Two people are pulling on ropes wrapped around the edge of a large wheel whose mass is 12 kilograms and the diameter is 2.4 meters. One person pulls clockwise with a 43 Newton force, while the other pulls counterclockwise with a 67 Newton force. What is the net torque on the wheel? Okay. So, there are multiple ways that you can draw this, and as long as the ropes are being pulled tangential to the wheel, you'll get the same answer. Now, when I first read this, how I viewed it was, here's my wheel, here's that point of rotation, and I have a force here. Now, that would cause clockwise motion, and so one person pulls clockwise with 43 newtons, and then the other person pulls counterclockwise, like this force is causing it to go counterclockwise, and it's 67 newtons. What is the overall net torque? We know that the diameter is 2.4 meters, so that means that this radius to that center point of rotation is 1.2 meters for both of them. Okay, that's how I viewed it. Something to keep in mind, this large wheel whose mass is 12 kilograms. Now, when we consider the mass of the object, we have to know where the center of mass is. We have to make assumptions about where the center of mass is. Because if the center of mass is at the point of rotation, then the force due to gravity times by r, where r is 0, it's 0 meters away from the point of rotation, it gives us a torque of 0, so it doesn't contribute to the torque at all. Now, for this example, I would say that the center of mass is right at the center, the point of rotation. So we don't have to consider it when we're thinking about torque. But this isn't always the case. Occasionally, the center of mass is somewhere else other than that center point of rotation, and then you do have to consider the torque that would happen because of that. Okay? So we don't have to worry about that. Let's call this torque 1 and torque 2. Okay? Torque 1, and remember, torque in general is force perpendicular times by r. Well, this is all perpendicular. Like if this is my lever arm, this force is perpendicular and that one's perpendicular. So it's the entire 67 newtons times by r, which is 1.2 meters. And then torque 2 will be 43 newtons times by r. Okay, 67 times by 1.2, which equals 80.4 Newton meters, and then 43 times by the 1.2 is 51.6 Newton meters. And now I'm going to do the sum of the torques. Okay, the sum of all these torques, well, torque 1 is pulling counterclockwise, so that would be a positive. So we have a positive torque 1 plus, because it's the sum, of a negative torque 2 because it's causing clockwise motion. If the torque causes clockwise motion, it's a negative torque. If it causes a counterclockwise motion, it's a positive torque. Okay? And so I could rewrite that. It's torque 1 plus, or sorry, subtract the torque 2 instead of adding the negative. And torque 1 is equal to 80.4 Newton meters, and I'm going to subtract that from 51.6 Newton meters. So I will take 80 minus 51, and I'm going to round that up to 29 Newton meters. And it's a positive, so that means that what's going to happen in this situation is the object's going to rotate counterclockwise. Okay, that's example problem number 6. So at this time, go in and do your concept check and take that as many times as you need to get 100%, and then the assignment will open up once you get 100% on that concept check.